Hey guys, welcome to chapter 9. We're doing radicals this chapter, so that's like square roots and such. So today we're going to be doing 4 objectives. They're all pretty simple objectives, that's why we're able to do 4. So let's look at them. First one is finding a square root. So, in case you don't know, a square root is the opposite of squaring a number. A square root of 25 is 5 because 5 squared is 25. The square root of 25 can also be -5 because -5 squared is 25. The square root of 1/4 is 1/2 because 1/2 times 1/2 is 1/4. So a square root is asking you what number times itself is the number underneath the square root symbol. So let's talk about those symbols. The square root symbol is called a radical or a radical sign, and the expression under the radical is called a radicand. So the blue is the radical, the pinkish red is the radicand. The number inside is the radicand. I remember that because it's got an N in it. It's inside. I don't know. So we're going to do some quick square roots here. What's the square root of 36? So what number times itself is 36? So that would be 6. The square root of 36 is 6. If there's a negative out front, it's asking you what's the negative square root of 16. Well, do the square root of 16. What's the square root of 16? Well, that's 4 because 4 times 4 is 16. The negative just floats along. With fractions, you're just going to do the numerator and the denominator separately. So what's the square root of 9? 3, because 3 times 3 is 9. And what number times itself is 100? 10. 10 times 10 is 100. So that equals 3/10. The square root of 0 is 0, in case you were wondering, because 0 times 0 is 0. And then with decimals, 0.64, you can think of it as 64. Well, 64 is 8 times 8, so that's going to be 0.8. If you want to pause here and try the next 5, that would be awesome. Otherwise, here we go. The square root of 481st is 2/9 because 2 times 2 is 4, and 9 times 9 is 81. The square root of -25 is -5. The square root of 144 is 12. 12 times 12 is 144. 0.49 is 0.7 because 7 times 7 is 49. And that would be -1. Now, that leads us to number 11. Is there a real number solution to the square root of -4? So you have to think about this. What does it mean to be the radicand? It's asking you what number times itself is -4. So there are 2 options, right? It's either 2 or maybe it's -2. So let's look at those scenarios. Well, what's 2 times 2? That's 4. That is not -4. What is -2 squared? What's -2 squared? Well, that would be -2 times -2, which is also 4. So you see, there's no number times itself that's going to be a negative number. So if there's a negative inside of the radical, there is going to be no real solution. A square root of a negative number is not a real number. So anytime there's a negative inside of a square root, it's going to be no real solution because nothing times itself is going to be negative. Okay, so we're going to move on here. That was square roots. We can also do cube roots or fourth roots or any root. So a cube root is asking you, instead of a square root, it's saying what number times itself 3 times is whatever the radicand is. So, for example, 2 to the third, 2 times 2 times 2 is 8. So 2 is the cube root of 8. In symbols, you'd write it like this. The cube root of 8 is 2. So this little number up there is called the index. If there's an index, that's telling you what root you're doing. If there's not an index, it's an understood 2 for square roots. There's understood 2 for the index. So some more. The cube root of 27 would be 3 because 3 times 3 is 9 times 3 is 27. The cube root of -64, notice there's a negative inside of that radical, is -4. So you'll note because -4 times -4 is +16, and +16 times -4 is -63. So notice that unlike a square root of a negative number, the cube root of a negative number does exist. So you can take the cube root of a negative number. You cannot take the square root of a negative number. And really, this is the case for any odd index, you can have a negative inside. Any even index, you could not have a negative inside because an even amount of negatives is going to end up being positive. So Let's look at some of these examples. The cube root of 1, that's asking you what number times itself 3 times is 1. Well, obviously 1 times 1 times 1 is 1. The cube root of negative 27, we know it's going to be negative. What number times itself 3 times is 27? We already kind of had it up here. 3 times 3 is 9, times 3 is 27. 1 1/25, the cube root of that. So do the top. What's the cube root of 1? 1. On bottom, what's the cube root of 125? Well, it ends in 5, so 5 is a great guess. 5 times 5 is 25, and 5 quarters is $1.25. So the cube root of 125 is 5. Cube root of 0, still 0. The cube root of negative 64, I had it up here, it's negative 4. The cube root of 1/8, the cube root of 1 is 1. The cube root of 8 is 2, because 2 times 2 times 2 is 8. All right, we're going to bump it up. We're going to have more roots. Okay, so we can have any index that we want. So just like with square roots, I already said this on the front, you cannot have a negative number inside the radical with an even index. You can have a negative number inside of the radical with odd indices. I put big stars on there, so pay attention to that. Okay, the fourth root of 16. So what number times itself 4 times is 16? You know what? I'm going to show you how to do this on your calculator. Now, I have a little bit of a fancier calculator today, but I'll show you how to do it. So if you want, so our problem is a fourth root. So the first, you can do this on your calculator too. If your index is a 4, the first thing you're going to do is hit 4. Okay, and then on your calculator that you have, I don't have it on my calculator, but I can kind of tell you where it will be. If you look at your square root button, right above it is a little square root with an X there, and that's the one that you want. So you hit second, the one above the square root button, and it will look like this. Let me show you what it looks like. Oops, 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 oops. It looks like that. See number 5 there. That's the button you're looking for. And what that means is the 4 is taking the place of the little blank space there. So it's saying the fourth root of, then you type in the number, 16, and it will spit it out for you too. And you'll notice, you do have a square root button as well, so you can use that. Just be careful with fractions, because if your problem has a fraction, your answer should be a fraction. All right, fifth root of negative 32. So again, let's practice that. 5 for the fifth root. Then you're going to hit that second button. I don't have the calculators that I use at school. I just have my good calculator here. The fifth root of negative 32 is negative 2, because negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is negative 32. The cube root of negative 8, we should know that one. It's negative 2. The fourth root of negative 81, we'll just type that one in again. I know what it is, but it's fine. The fourth root of negative 81. Oh, what's that? Non-real answer. Why is that? Oh, look at that. I had an even index with a negative inside. So this is no real solution. So remember, even index can't have a negative inside of that fraction. We can, however, take the fourth root of positive 81. So the fourth root of positive 81, it's 3, because 3 times 3 is 9, and 2 of those would make 81. The fifth root of 10,000, well, I know that there are 5 zeros in there, so 10 times 10 times 10 times 10 times 10 times 10 is going to be 100,000. I'm not even going to type that one in. I see that even index, a negative number, no solution. Cube root of negative 125. The cube root of negative 125 is negative 5. Okay, so there you go. Now, what happens if your number is not a perfect square inside of the radical? 1, 4, 9, 16, 25, those are perfect squares because 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, and so on and so forth. Those are perfect squares because it's something times itself. It's a perfect square. It's a number squared. Now, numbers that aren't perfect squares simplify to what's called irrational numbers. And an irrational number, you should remember, is a non-repeating, non-ending decimal. So it's a number that goes on forever and ever in a non-repeating fashion. So What we can do with irrational numbers is most of the time we're going to leave them in simplest radical form, but today we're going to get a 3 decimal approximation with our calculator. So all we have to do is type it in. So again, we're going to second, that square root button. Be sure to close that parenthesis on that square root button. It gives you a parenthesis on that one, while the other ones don't. So we're going to do a 3 decimal approximation. That 0 would not round that 2 up, so it's going to be closest to 1.732. The fourth root of 137. So again, 4, hit that root 137. Rounded to 3 decimal places is 3.421. We're just making sure you can type things in your calculator today. Isn't that great? Square root of 17. Close that parenthesis. 4.123. That's a fun one. And the last one, the fifth root of 763 is 3.771. None of them rounded up. How sad is that? Remember, if that fourth number was a 5 or higher, it would round that one up. Don't forget that, okay? That's it for today. As you can see, it's pretty simple stuff. Let me know if you need any help, though. I'll be glad to help you out. We'll talk to you later. Have a great day. It's a great day to be a mathematician, y'all.